So sure. Okay. So good afternoon, everybody. My name is Mohammed Mahmoud. Okay. I'm the instructor of 2140 Introduction to Digital Systems. Before I start, I sent 3-4 emails in the last couple of days. If you have not received an email from me, that means you are not in my mailing list. Please email me your email to add you to the mailing list. Okay. So this is actually my office. My office is in Brown Hall 332. This is my email. This is my website, but it doesn't work right now because this server is down. Anyway, so and in this course, we're gonna have 2 TAs. At least we have one right now. So there will be another TA. The TAs should help mainly on labs, grading, and also projects. As you know, our lectures are going to be Mondays and Wednesdays from 1 o'clock until 2:15 in this room. If you on Mondays, I have a lecture right after this lecture in Brown Hall. So I have to, after I finish this lecture, I have to run quickly to the other lecture. So I'm really sorry for Mondays. If you want to talk to me after the lecture, I will not be able to do that. But for Wednesdays, I'm okay. I don't have anything. Also, if you need any help at any time, just email me. I already several students emailed me, and I responded to their emails. Okay. The labs are going to be in Brown Hall 407. So lectures are here, but labs are going to be in Brown Hall. As you know, or I already emailed you about that. I think, let me think. Hello? Seems to me it's not working. Let me see if I can use another one. I'm recording the lectures because I'm gonna post the recording just in case you miss something in class. So just give me 1 second.
So is that microphone going to a sound recording on?
Maybe I need. Yeah. Hello. Yes. Yeah. I think you can hear me right there. Is that okay? I don't need a microphone to hear me. Is that right? You can hear me? Yeah. So just no. My concern is in the recording here. Yeah, it seems to start to work. I can see something here. Okay. Yeah, it's fine now. Okay. Anyway, so as I told you, all the course material are gonna be posted on iLearn. I already posted what chapter, I call it chapter 0, which is the syllabus actually. Also, I posted chapter 1. As I do more chapters, I'm gonna post the slides. As I told you, I'm gonna record all lectures just in case you miss something. You wanna listen to the lecture again. So I'm gonna post all of them on iLearn. For if you need anything from me, you are very welcome to send me an email. Okay. Again, my email here is here, and I think you can find also my email in iLearn. So this is my email is here. Yeah, so let's start with the course description. This is how the course is described on catalog. So it's analysis and design of digital system, number system, Boolean algebra, combinational and sequential logic circuits, state machine design, and other stuff here. Okay. For the textbook, I'm going to use this textbook. Also, we are going to use Zybox. For Zybox, this is the instruction you need to use it. I think you should have used it before. You are familiar with it, right? So this is the code you have to use. Okay, it's under the name of Dr. Bruce because he was supposed to teach this course, and there was a change in the last minute, so still under his name. But I'm the only instructor for this course. Okay. Hello? Hello? Let's see. Yeah, I think it should be okay. Hello? Let me see if I can use this one. Hello? Hello? I'm gonna just keep this one and see what's gonna happen here. Hello? 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 Just you can use. Okay. So this is the code you have to use here. Okay. You don't need to write this code because it's already this slides on iLearn anyway. So you need to use this code. So any question about Zybox? You are familiar with it, right? Okay. This is for the course evaluation. The homework is going to be 15% of the final grade. We're going to have one project. This project is 10%, labs 25%, quizzes 15%. Some of these quizzes are going to be here in the lecture. Some of these quizzes are unannounced, some pop quizzes, some other quizzes. I'm going to tell you about them. Okay. We're going to have two tests, 15%, and the final exam is 20%. Any questions? Yeah, sure. Yes, the two tests, 15%. Yes. So if you add, the total is 100%. Any questions? Good. So as this is the standard for any course to get an A between 90 and 100, B between 80 and 90, and so on. This is the standard one. For sure, as an instructor, I have to tell you any academic misconduct is not going to be tolerated, and no one will tolerate something like that. It's not allowed to copy solutions from others. This may be different from labs because in labs, every two students are going to be working together. So it's okay if you can work together, it's okay. But homework has to be done individually. Okay. Here I give you some advice. I give you some expectation. I expect that you attend the lectures and lab. Your participation is important. If I ask a question, I hope if you can reply to me. You have to do homework, labs by yourself. You have to be on time. If you come late, please don't make noise. Don't make any disruption. Yeah. I want you to focus here during the lectures. If you have any question, raise your hand. I told you in one email, I want you to print the notes and take notes. Actually, you don't need to print. If you can take notes on tablet or anything electronic, it should be okay. But I just want you to take notes, and if you don't understand anything, okay? As you will see in the slides, the way I teach, I make very detailed slides. Okay, so I put a lot of details in the slides, very detailed. One more thing here. Maybe it's a good idea if you can read the slides before you come here. I think this can be very useful. If you need any help, it's your responsibility just to contact me. I'm responsible to help you. I'm here to help you. Okay. So don't be shy. It's not bad. If this is my job is to help you. Okay. If you need help, just email me. I will do my best to help you. Okay. I will be very happy if you understand this course. If you love the course, I will be very happy. Okay. So, but just tell me that's all what I need from you. If you need help, just let me know. Okay. One important thing here, maybe not all quizzes labs have the same weight. You got what I'm saying? Because they may not have the same difficulty. They may be different weights. So you have to be careful about that. Okay.
normally going over? Is it going to be going over like the vocabulary, like that we did in programming last semester, or is it going to be over a multitude of different things that may be undetermined?
Quizzes will be about what I'm teaching here. Okay. So, and this course does not have programming. So I'm gonna tell you when I teach. I'm gonna tell you in the quiz. I will ask you question here, question there. Okay. I just want you to learn it and solve it in the quiz. So don't worry. I will let you. Okay. I think that's all what I have. Any questions before I start chapter 1? Yeah, sure.
Are the tests cumulative? Like, will the final test be covering all the material in the entire?
So answer has to be yes.
Okay.
Why? Why? I'm going to tell you why. Because as after I teach you this course, you will understand I can't separate. Because what I'm going to teach in the first lecture, I'm going to teach you today how binary numbers, how you do the conversion. You are going to need in the last lecture. It's going to be very hard to separate, to tell you. But for quizzes, I'm going to tell you, the quiz is going to only focus on this part. You can see, but the answer is yes. Okay. Any other questions? Okay. So I'm going to start chapter 1 here. Okay. So this is chapter 1, even in the textbook, it's the same name, digital system and binary numbers. So here I'm gonna start with number systems and convergence, how to convert between different number systems. So let me ask you a question. What language you are speaking right now? I'm speaking English, right? You are speaking English now, okay? Is English the only language or there are other languages? The answer, there are other languages. We have Spanish, Chinese, many other languages. Is that okay? Same thing for numbers. So for numbers, we are familiar with 217. I'm right? 331. We are familiar with this system. Is that okay? That's what we're familiar. Is this the only system? The answer is no. We have the other system, but we don't use it in our daily life. Okay? But we need them in this course. I'm going to tell you why. Okay? But you should understand, similar to languages, we have different system for numbers. Okay? Different what the system we are using in our daily life is called decimal numbers. Okay? And as you know, in decimal numbers, we use digits. The numbers we have, we represent them in digits from 0 to 9. Is that okay? Like 317, 226, whatever. Okay, so this is the digit we are using is actually from 0 to 9. So how many digits we are using? 10, right? From 0 to 9 is 10. That's why we are saying the base is 10. So the number we are using in our daily life, the base is 10. Why? Because with any number, to make any number, we use 10 digits. What? Okay, combination of different from 10 digits. Is that okay? So that's why this one we call it the base is 10. Okay. We have other systems. Okay. The second one I'm going to explain, we call it binary number. Also, we have octal number. We have hexadecimal numbers. Okay. In English, by binary, the word binary in English means 2. Octal means 8. Hexadecimal means 16. That's true. Okay. Because here in binary numbers, the base is 2. What do you mean? What do you mean the base is 2? That means to write any number, I'm going to use only 2 digits. Okay, 2 digits. Similar to here. Here we use 10, right? We use the 10 digits here, but here we use only 2, 0 or 1. Is that okay? That's why any number is just 1, 0 and 1. Okay, so you can say 0, 1, 0 or 1, 1, 0, 1. So these are binary numbers. Okay, any number 300, I can represent it using 0 and 1. 220, I can represent it using only 0, 1. Is that okay? For octal numbers, the base is 8. That means the digit we are going to use is actually from 0 to 7. That means we don't have 8, we don't have 9, we don't have all of that. Only the digit we are going to use here is from 0 to 7. Okay. For example, I can say 372. 372 in octal is different from 372 in decimal. It's a different system. Yeah, you will understand better what I'm saying as I explain, okay? As we go through. But here, the basis 8 means we are going to use digits from 0 to 6, okay? In case of octal numbers, okay? Also, in case of hexadecimal, the base is 16. That means we have 16 digits. So any number I'm going to use should have these digits, or it should be, or it has to come from these digits. Okay, 16 digit. So the 16 digit we have here right now is actually 0 to 9, okay? And this can make 10. And then I'm going to use A to F. So I'm going to use A, B, C, D, E, F, okay? Give me example. As example, I can say 3A2. This is hexadecimal number. I can say 32 hexadecimal. Okay, but 32 can be decimal. That's true. It can also be octal. That's true. It can't be binary. That's true, because in binary we use only 0 or 1. Cannot be 3 or 2. Is that okay? But when I say, for example, 32, it actually can be decimal, it can be octal, or it can be hexadecimal, because it's allowed to use digit 3 and digit 2 in these systems. Is that okay? But wait a second. So how I can tell, if you tell me 32, it can be this one, this one, this one. Is that something I can guess? No, you shouldn't guess. Okay, that is why we're gonna use something like that. Look here, guys. Here, for example, 190. This digit can be in decimal, in octal, in hexadecimal. I can't guess. What do you mean? You have to tell me what do you mean, right? So how can I tell you what you mean? Very simple. Just you put here this prefix here, or the subscript here, right? Here, because this one is 10, that means I'm telling you this number is decimal. When I put here 8, that means this number is octal. When I put here 16, that means it is hexadecimal. When I put 2, I forgot to add 2 here. When I put here 2, like 1010, that means this is one in binary. So I have to tell you. Is that okay, guys? Okay. One important thing also, for example, 10, for example, 10, okay? In 10 in decimal, it means 10 items. When I tell you I have 100 iPhones, sorry, I have 10 iPhones, that means I have 10 iPhones. Is that okay? Okay. But if 10, if 10 is actually 2 binary, it's binary, that means this means I have only 2, not 10, it's 2 iPhones. So when I tell you I have 10, okay, in binary, that means I have 2. 10 here means 10, okay? Don't worry, I'm going to tell you how to do the conversion. I just want you to understand 10 here in decimal is not the same like this one, it's not the same like octal, it's not the same in hexadecimal. So 10, for example, in octal means 8. We have 8, okay? 10 in hexadecimal, it means 16. You got what I'm saying? As numbers, it's going to be different because different systems. Okay. Anyway, so the conclusion before I move forward here in this section, I'm explaining we have different ways for numbers, different ways to represent numbers. This is the one we are familiar with. This one, we use this one in our daily life, okay? But it's not the only system. We have other systems we need. So what I'm going to explain right now, conversion, how to convert. If you have a number from here to convert to here, or from here to here, or to here to here, or also I'm interested to convert binary to octal, binary to hexadecimal. Is that okay? So now I'm going to focus on conversion. How you convert from one system to another. I told you, but I didn't tell you how I did it. I told you if you have 10 of 10, that of decimals, that means 10. If I have 10 of 8, that means 8. If I have 10 of 16, that means 16. 16 items, okay? But I didn't tell you how I did this convergence, okay, in decimal. For sure, I'm gonna explain that. Also, I need to explain why in these courses we are interested in these numbers. Why interested? All our life in math and everything, we just use this one. So what happened? Why you are going to use these ones? Okay, so for sure you will understand. But I can quickly tell you, because this course is about digital systems. Okay, you will understand in this course what I mean by digital system. Okay, digital system means, for example, you have here a hardware circuit. That's what we're going to design in this course. This hardware circuit, you can input here numbers in binary, for example, 0101, okay? And then you can get output from here. If this circuit is doing addition, I can add using hardware in binary. I'm going to get the output here also in binary, okay? If this circuit is doing multiplication, we're going to do multiplication. If doing something else, it's going to do whatever it's doing. But all the circuits we are going to, or everything we're going to explain here in this course is going to be binary, okay? One more thing, maybe it's little bit early to explain, but just to, I want you to understand the story. Maybe you already have heard that computers can only work on binary number. Maybe you heard it, okay? That means if you write a program in C, Java, Python, or whatever, any language you are using, okay? When you run this program, the hardware doesn't understand what for loop. This is your own language. It doesn't understand what is while loop. Is that okay? Anything you run by using computers, and computers can be iPhone, by the way, so iPhone is computer, okay? Processor, it has a microprocessor, okay? Anything run by the microprocessor, it has to be executed by hardware, right? Hardware, okay? That's why we need the hardware to do addition, we need the hardware to do multiplication, and all of that. And this is the purpose of this course. So in this course, I'm going to teach you how I can design a hardware circuit to do addition or multiplication. And this operation, this is the basic component of any computers. You got what I'm saying? Here, I'm not, in this course, we're not going to teach computer architecture. So in this course, you may not understand how computer works, but I'm going to teach the building blocks of computers, right? So here I'm going to teach some hardware circuits. One is, for example, adder, multiplication, flip-flops. So, and then in the future, when you take like computer architecture courses, okay, we are going to use these building blocks to create computers, because you should understand in computers, instructions have to be done by hardware. That is why you use compiler when you write something. When you write something by high-level programming language, you need to convert it to assembly language. And assembly language, we call it the machine language. Why? What do you mean by machine language? I mean, and that's what you should learn in 3130. I used to teach 3130, okay? In 3130, you are going to see, I think most of you didn't see, all what you see right now is high-level programming language. You see for, while, whatever, okay? Believe me, hardware doesn't, this is your own language. Hardware doesn't know it, right? That's why you need a compiler to convert what you want to do here in for. I have to convert it to machine code, machine instructions. And then by executing this instruction by the machine or by the hardware, you are going to do the for, or you're going to do while, and so on. Okay? So let's agree that any digital systems, okay, only understand binary numbers, or only work on binary numbers. And there is a reason for that, but I don't, as I teach more, you will understand this better. Okay? So to execute, that's what I'm going to teach here in this course. How can you design circuits? This circuit can take some input binary number, do some operation, do some calculation, operation, whatever, it depends on what I'm teaching, and then at the output here you get binary number in the output. That's why you are very interested to learn binary number. I'm going to teach hexadecimal octal for other reason. But anyway, I was answering a question why in this course we need to learn other numbers. Why we need it? Simply because this is our own language. This human, we're using this one. Hardware is using this one. Okay, I'm gonna tell you about the other ones, but let's start now focusing. Any question here? You understand numbers? I can represent any number. I can represent it in any one of these systems: decimal, binary, octal, hexadecimal. You got what I'm saying? But you are only familiar with this one. That's what we use in our language, our daily life. But this is similar to language. Most of the time you are using English, but that doesn't mean English is the only language, right? You know, any questions? Okay, so now I'm gonna start. How can you convert any base to decimal numbers? Is that okay? So let's start with how can you convert binary to decimal number. This is a binary number. I'm telling you it's binary, and even you can see it only has ones and zeros. Okay, but also I have to tell you it's binary. So if I have a binary number like this one, before I teach this one, I want to tell you something you're already familiar with. Okay, for example, when I say 372 in the second grade or third in second grade or first grade, you were told that this one is in ones, right? This one is in tens, and this one in hundreds. You understand? Okay. So I'm gonna say the same thing, but I'm gonna in a different way. I'm gonna tell you the weight of this one is 10 to the power 0, which is 1, right? The weight of this one. So the 2 here means 2 times 1, which is 2. The weight. But this one is in tens. So that's why this one, the weight, any number you put here, the weight of this number is 10 to the power 1, okay, which is 10. Next one here is 10 to the power 2, which is 100, okay? Next one, 10 to the power 3, 10 to the power 4, and so on. The weight, you understand what I'm saying? Because here you have 7. So actually it's not 7, it's 70, right? So any number here in tens, okay? So here every digit has a weight. And we as we move from right to left, not left to right, right to left, the weight increases. Makes sense? That's what we do, right? Okay. So the weight of this one, 10 to the power of 0. The weight of this one is 10 to the power 1. The weight of this one, 10 to the power 2, and so on. Okay. So same thing here in binary numbers. So if I go to binary numbers, I'm gonna do exactly same thing. This is a number, binary numbers this way. It's the same thing. I'm gonna move right to left. Okay. The first number here has a weight of 2 to the power 0. So whatever you put here has the weight of 2 to the power 0. This one has the weight 2 to the power 1. This one has the weight 2 to the power 2, and so on. Is that okay? So as you move this way, the weight increases. Okay. So now the question is, if I give you a binary number like this one, and I ask you to convert to decimal, convert this number to decimal, what can you do? Okay, very, 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 very simple. Look, multiply every digit here by its weight and add everything together. Very simple. See what I did. The weight of this one, as I told you, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the 6, 2 to the 7, whatever. Okay. So everyone has a weight. Be careful here. The weight here, 2 to the power of something, right? In decimal, when I write, so for example, 372, the weight of this one, 10, because here this is the basis of 10. The base is 10. So here, 10 to the power 0, the weight of this one, 10 to the power 1, this one, 10 to the power 2. Okay? 100, ones, tens, hundreds, and so on. Okay? When I come to octal, it's the same thing. The weight is going to be 8 to the power 0, 8 to the power 1, 8 to the power, it's the same thing. When I come to hexadecimal, it's the same thing. 16 to the power 0, 16 to the power 1. Okay? Right to left, not left to right. Okay? So all what you have to do here, if you have this binary number and I want to convert this binary number to decimal, all what you have to do, just as you see here, this is 1. Okay, so I'm going to multiply 1 by its weight. This is 1. I'm going to multiply 1 by its weight. I'm going to multiply 0. You don't need, actually, you don't need to do this one because you know 0, 0, and 0 multiplied by anything is 0. You know that, right? So just waste of time. So you should only focus on on the ones because 0, 0 multiplied by anything is 0. Okay. So I'm gonna so here 1 to multiplied by the weight, which is 2 to the power 0. Okay, you get 1. 1 times 2 is 2, and so on. So I'm gonna continue this way. Okay. So and then after that, I'm gonna add everything together. After you add everything together, you got 219. That means this number is equivalent to 219 in decimal. Look at this one here. Any questions? Yeah, sure.
Is hexadecimal very similar to binary, but instead of using 2s and 8s?
Hexadecimal?
Yes.
In hexadecimal, we have 16 digits from 0 to 9. Let me go back here. 0 to 9 and A to F. So any number can have digit from these ones. Okay, it doesn't need to have all of them, but it has to be in these ones, right? That means it can be, for example, 3A. It can be 30. Any digit from this one can be hexadecimal. Okay, but for this one, for example, in octal, we have from 0 to 7. So I can't put 8. I can put 9. No, is this the digit? These are the digit you have to use in this number. Okay, good. So by the way, if I come to, when I say, for example, 317, okay, we agree the weight of this one is 1, which is 10 to the power 0, which is 1. The weight of this one, 10 to the power 1, which is 10. The weight of this one is 10 to the power of 2. Okay. If I do the same thing I have just did right now, it's going to work. For example, it's going to be 7 times 1 plus 1 times 10. So plus 3 times 10 to the power 2, right? So what I'm doing here, just multiply every digit by the weight, okay? So that means this one is contributing by 7. This one is contributing by 10, right? So it's going to be 10 to the power of 2. 10 to the power of 1. This is 10 to the power of 0. 2 is here. The third one is 3 times. If you add them together, you are going to get 317 as well. What I'm saying? So anyway, let's come to my point. My point is very simple. If I, number one, if I give you a binary number, number one, I have to tell you this is binary because this number can be decimal. This number can be decimal, right? It can be octal. It can be hexadecimal. So number one, I have to tell you. How I tell you? Very simple. I have to put parentheses this way, and I have to put here 10. Okay, and that's what. Sorry, I have to put here 2 if it is binary. That's why I did it here. Okay, this is number one. Number two, because this is a binary number, you can only use digits 0 or 1, nothing else. But okay, I can't use 2. I can't use 3. There's no 2 or 3, just 1 or 0. Okay? Number 3, if you want to convert this one to decimal, very simple. Just to multiply every digit by the weight of this digit. And for the weight, you have to come from here to here, from right to left. Everyone here is going to be, the weight is 2 to the power 0, 2 to the power 1, and so on. Okay, that's what I did. Multiply the digit 1 times the weight. The result is 1. 1 times the weight. The result is 2. Add everything together, I got 219. That means this number in hexadecimal is equivalent to 219 in decimal. Sorry, this number in binary is equivalent to 219 in decimal. Any questions? Okay. Any questions? just if I tell you something like that, A, 0, 2, A, and this is binary. No, this can't be binary, right? Because in binary, we have to use only 1 and zeros. Okay. Anyway, any questions? Okay. Now, if I give you a number in octal and I want to convert to decimal, exactly the same thing. I'm going to repeat the same thing I did right now. But the weight here, instead of using 2 to the power 0, 2 to the power 1, I'm going to use 8 to the power 0, 8 to the power 0, because the base is 8. Okay. And this is, so before I go to that, I want to explain to you if there is a point. Here we call it a binary point. If there is a point, how can you convert this one? Okay. If the number has a point, it's very easy. It's exactly the same thing again. You have to multiply every digit by its weight and then add everything together. Okay. So you already know the weight of this one here after the point, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Before the point, it's going to be 2 to the power of -1, 2 to the power of -2, 2 to the power of -3, 2 to the power of -4. By the way, this is the same thing we are doing in decimal numbers, but instead of 2, we do 10. For example, you have 3.72. So the weight of this one is actually 10 to -1. Is that okay? Which is 1 over 10. This one, the weight of this one is actually 10 to the power of -2, and so on. It's exactly the same thing. But just instead of using 10 here, I'm using 2, because this is the base. In octal, I'm going to do the same thing, but instead of using 2, I'm going to use 8, because this is the base. Hexadecimal, I will do the same thing, but instead of using 8, I'm going to use 16, because this is the base. Any question? So again, if there is a binary point here, the way you are going to convert it, similar, just to multiply every digit by the weight. And the weights after the point, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Before the point is 2 to the power of -1, 2 to the power of -2, -3 as you move this way. Okay, so that's what I did. After I do this multiplication, I got here 8, 4, 0, 1, 0.5, 0, whatever. I added everything together, I get this number. So this number is actually in decimal, is equivalent to this number in time. Any questions? You have another example here. Again, I'm going to multiply every digit by its weight. Multiply this one by the weight. Multiply this one by the weight. Multiply this one by the weight. Add everything together. I got, so this is in binary, is equivalent to this number in decimal. Sorry, this number in binary, this is decimal. This is in binary. Okay. Any questions? Okay. Now, so now you should know, if I give you a binary, you should know number one. If you should understand how correct binary number should be. Very simple. It should have digits 0 or 1. Very simple, right? Also, you should know how can you convert binary to decimal. Is that okay? Now I'm going to repeat the same thing, and you will see the similarity, right? I'm going to move to octal and hexadecimal, and everything will be the same. But instead of 2 to the power of something, it's going to be 16 or 8. This one is a base. So let's move to octal. So as I told you, octal numbers should have digits from 0 to 7. Okay. For example, 80 is not an octal number, right? Because it has 8. There is no way I can't use it in octal number. Is that okay? For 140, okay? This number, it can be decimal, it's allowed to be decimal, it's allowed to be octal, it's allowed to be hexadecimal. It's not allowed to be binary, right? Okay. Anything else, as long as the number is using digits from 0 to 7, it can be an octal number. Like 70, it can be an octal number, and so on. So if I give you this number and I tell you this is octal, because this is not something you can guess, you need to tell me. So I give you this number, and again, the way I'm going to tell you is this way. Look here. You have to put 80, right? To tell you. Okay. Anyway. So if I give you this number, okay, 140, and I tell you this is an octal number, I tell you I want to convert this number to decimal, similar to what I did before. The weight of this one is 8 to the power 0 because this is base 8, right? The weight of this one 8 to the power 1. The weight of this one 8 to the power 2. And that's it. So all what I have to do, I have to multiply every digit by its weight. Add everything together, I got 96. Okay? So that means if I tell you, listen to me, so that means 140 is equivalent to 96. Is that okay? So if I tell you I have 140, okay, apples, for example, I have 140 octal apples, that means in reality I have 96 apples. If you count them, they are 96. Is that okay? Any questions? Very easy, right? So in a quiz, if I give you a number, I tell you convert it to decimal. It's going to be difficult. Okay. Now move to the next one. Hexadecimal. Oh, before I move to the next one, I want to show you if there is a point. Okay, how can you do it if there is a point? Again, similar to what I explained before. Here, after the point, the weights actually 8 to the power 0, 8 to the power 1, 8 to the power 2, 8 to the power 3, and so on. Okay, but before the point here is going to be 8 to the power of -1, 8 to the power -2, and so on. Okay, that's it. So again, I'm going to multiply every digit by its weight. Add everything together. I converted this number from octal to decimal. Easy, right? So all of them are the same way. All what you have to do, you have to multiply every digit by the weight, and then by its weight, and then add everything together. And for the weight actually is the base to the power 0, the base to the power 1, and so on. But here, after that point here is going to be base to the power of -1, -2, and so on. Any questions? Good. Now, I want to convert hexadecimal to decimal. Remember, in hexadecimal, it's allowed to use this digit. In hexadecimal, it's allowed to use 0, 1, 2, 3, 4 until 9, and then it's allowed to use A or B or C or D or E and F. Okay? By the way, 0 in hexadecimal is 0 in decimal. Okay, 1 in hexadecimal is 1 in decimal, and so on until 9. 9 here is 9 here. Okay? But here, 10 is actually A. So if I tell you I have A apples in hexadecimal, that means I have 10 apples. Right? A means 10. Okay? B means 11. Always put. I shouldn't say mean, but it's equivalent to 11 in decimal. Okay? C 12, D 13, E is 14, F is 15. If you can count how many digits we have, 16. That's why it's called hexadecimal. Any questions? Okay. So if I have a number like this one, and I am telling you this number is hexadecimal, this number is actually 2C9B. Okay. By the way, don't be confused. Sometimes I use uppercase for the letters here. Sometimes I use lowercase. It should be the same. So sometimes I get it from different sources, but should be the same. You understand what I'm saying? So here, if I say A or A, it's the same. Okay. Sometimes I get it from different books, but that's okay. Okay. They are the same. There is no difference. Okay. So anyway, so again, if I give you this number, you have to take it right to left, because the weights from numbers right to left. Okay. The weights. Okay. So here, the weight of this one has the least weight. The weight of this one is 16 to the power of 0. Right. The weight of this one is actually 16 to the power 1, 16 to the power 2, 16 to the power 3. So all what I'm going to do is I'm going to multiply here B. How I can multiply B by 16 to the power 0? Okay. B is actually 11. Right. So I'm going to multiply 11 by 1. Here, 9. I'm going to multiply 9 by 16 to the power 1. C is actually 12. That's why you need in exams or in something like that, you need to. I even do it by myself when I convert, because is that 14 or 15? I don't remember. So what I do, I actually write it. So I write here 0 to 9. After 9, 10, A, B, C, D, E, F, 10, 11, 12, 13, 14, 15. So you need to write it this way so that when you have B, you put 11. When you have C, C is actually equivalent to 12. Okay? 2, I'm going to multiply 2 by this number, and then I add everything together, and then by this way, if I have this number in hexadecimal, this is equivalent to this number in decimal. Any questions? Okay. What about if I have this? If I have a point here, if there is a point, it's exactly the same thing as I explained before. Okay. So as you see here, E is actually 14. So I'm gonna multiply 14. And this one is actually 16 to the power 0, 16 to the power 16 to the power 2, and so on the way. And before the point here this way, it's going to be 16 to the power -1, -2. Okay. So again, I'm going to multiply every digit by its weight. Multiply it by its weight. Multiply this one by its weight. E is 14, F is 15, A is 10, C is 12. Multiply every digit by the weight and then add everything together. So I'm going to get the number in decimal. Any questions? Okay, good. Before I move forward, I want to tell you something, a term or expression I'm going to use all the time. Listen to me. When I say, for example, 372 in decimal, okay? 372 in decimal. By the way, this digit here, we call it the least significant digit. And the last one here on the left, we call it, this is the most significant digit. Okay? Can anyone, so when I give you a number, I tell you this, you have to look at, or we need to check the most significant or the least significant. You should know what I mean by least significant and what you mean by the most significant. Is that okay? So always, for any system, here I give you example for decimal, but this is true for any system. For any system, the number here at your right hand is actually the least significant. And the number here, the last one here on the left, is actually the most significant. Okay? And even if you are confused, look at the English words. Least significant, most significant. This one is more important than this one. Makes sense, right? Why? Because this one has more weight than this one. The weight here is just one. The weight really is 100. You got where this word came from? Okay, least significant. So this one is the least significant, but this one has the weight of 1. This one has the weight of 100. Makes sense? For binary, I'm going to use the term least significant bit. Okay, and also here most significant bit. Okay, because in binary, 0 or 1, we call them bit. So to be more accurate, digit can be anything is digit, right? So for any system, but when I say bit, I mean binary. Bits are only in binary. Is that okay? So that means I'm going to use the least significant digit or most significant digit for any system. It's okay, but most of the time, because actually most of the time we're going to use binary numbers. Is that okay? So that's why I'm going to use the term least significant bit and most significant bit. Is that okay? That means if you have a binary number like, or if I go back here. Yeah. So here, if I come here, when I tell you the least significant, this one is the least significant bit. Okay. This one here is the most significant bit. Make sense? Any questions? Any questions? Okay. Now, so now I finished. How can you convert any base to decimal? And actually, all of them are the same. All of them are the same. Just multiply every digit by the weight, add everything to this, and that's it. Okay. All of them are the same. all what we do, just I change the weight based on the base. Okay, any questions? Okay, now I'm gonna move to the other one here. I want to do the opposite. If I have a decimal number, how I can convert it to any base. Is that okay? So now I'm gonna start with binary. How I convert the decimal to binary. So now I'm gonna do the opposite. So what I explained, just to make sure you understand what I'm saying, what I explained here, I have binary and I convert it to decimal. Now I'm gonna explain the other way. If you have a decimal, how can you convert it to binary and hexadecimal and octal as well? Is that okay? Okay. Here, I used multiplication here. Here I'm gonna use division. When you convert decimal to any digit, and again, the good news is, again, all of them are the same way. Just I'm gonna use different base, right? All of them are the same. But that's why if you learn one, all of them will be the same, just I'm gonna use different base. So here I'm gonna do division instead of multiplication. Okay, so, but I just want to tell you something here. When I tell you 5 divided by 2, what should be your answer? 5 divided decimal, everything, I don't want to confuse, everything is decimal. 5 divided by 2 is actually 2.5, right? This is division, 2.5. Is that okay? Okay, but I wanna express this result in a different way. Instead of 2.5, I want to express the result in what we call a quotient and a remainder. Have you ever heard about this kind? Sometimes when we do division, I want to get the result, not with decimal point at this one, but I want to get it a quotient and remainder. Have you ever heard about this? I will get it before. Okay, so what this means? I'm going to tell you. This is very easy. Look, 5. So actually, I have 5. For example, there are 5 guys here. One guy, another guy, another guy, another guy. 1, 2, 3, 4, and 5. I have 5, right? I want to divide this 5 by 2. What it means? It means I want to create groups of 2 because you divide by 2. That means these 2 are going to be one group. This one, a second group. So now I have 2 groups of 2, right? So I want to, because you divide by 2, that means how many groups of 2 are in 5, okay? So now I have 2, and that's what we call a quotient. So the quotient is going to give you how many groups of 2 I can have. If you divide by 2, if I divide by 7, how many groups of 7 we have, right? So it's the same thing, okay? So that means if the quotient is 2, that means I have this 5 can have 2 groups of 2, right? And remainder, you can take from the English name, remainder, right? So the remainder, the remaining. So this one is not making a group. That's why it has to be a remainder. It's not making it's less than a group. Otherwise, if it's a group, I would add it to the groups, to the quotient, right? That's why here, remainder, I have one remainder here. Any question here? Remainder means it has to be less than the group size. Otherwise, I would add it to the quotient, right? Okay. That is why, very important, that's why if I divide by 2, the remainder has to be 0 or 1. It can't be anything else. It can't be 2. Okay, because a remainder has to be less than a group. Less than a group, and the group here I put group of 2, right? So here that means if you divide by 2, the remainder has to be 0 or 1, less than a group. If you divide by 7, it's the same thing. For example, if you divide by 7, that means the remainder has to be 0 to 6. It can't be 7. Because if it's 7, I would make a group and add it to the quotient. Any questions? Any questions? Okay. So, why I'm explaining that? I'm explaining that because when we convert the decimal to any base, we need to get quotient and remainder. I'm not going to do it 2.5. I need to know what is the quotient and what is the remainder. Okay. Okay, but how if you are using the calculator? I'm sure there is some way using the calculator you can get it, but most of the time the calculator is going to give you something like that. So if I have this answer 2.5, how I can extract the quotient and the remainder from this one? Is that okay? Very easy. Look what I'm going to do. This number here after the point, this is the quotient. Okay, so now I have 2, right? So quotient is 2. Now this half a group. So I'm going to take half. That means this one has 2 group and half a group. So here I'm going to multiply half by 2. Remember, we originally were dividing by 2. So I'm going to multiply it by the group size. It's going to give you 1. That's what I'm saying. So take the fraction part, multiply it by the base. It's going to give you because this means I have 2 groups, which is the quotient, and then I have half a group. Group T means this one because I'm making groups of 2. Any questions? Any questions? Now let's see. I'm explaining how can you convert a decimal number to any base. Okay, so this is the way you are going to do it. For example, if I want to convert a decimal to binary, okay, so here I have this decimal number 47. Okay, so I have 47. The equivalent number of 47 is actually this number in binary 101111. Okay, in binary. So this is equivalent. These two numbers are equivalent in the 2 different systems. 47 is equivalent to this one. Is that okay? How you did the conversion? I'm going to tell you how. Okay? Very simple. I'm going to divide by the base, as you see. So as you see here, the way I'm going to do it is, and the way, if you understand this one, next one, octal, next one, hexadecimal, are the same thing. But instead of dividing by 2, I'm going to divide by 8, I'm going to divide by 16. Okay? Anyway, so let's do this one. 47 divided by 2. Okay? So I'm going to get a quotient of 23. So this is the quotient. Okay? And the remainder is 1. Keep the remainder. Because every time you do one division, you are going to get one digit. Okay? And when you get one digit, it's going to be right to left. Look here, you will see. I'm going to get the digit right to left. Every time, as you see here, I'm going to get the quotient divided by 2 again. Okay? The quotient is 11. The remainder is 1. So every time you do one division, I'm going to get one digit right to left. So the first one you are going to get is actually the least significant digit. Is that okay? So again, what I did, 47 divided by 2, the quotient is 23, the remainder is 1. This remainder is actually the first or the least significant bit here. Okay. Then I'm going to get the quotient again, divided by 2. Okay. I got 11. This is the new quotient, 11, and the remainder is 1. So I got the second one here. Okay. And so on. So I'm going to continue this way, divided by 2, as you see it continue, until I get quotient of 0. At this moment, I have to stop, right? Because if you do it, you are going to get remainder 0, 0, 0. So I have to stop when the quotient is 0. So actually, here when you have, for example, here 2 divided by 2 is 1, and the remainder is 0. There is no remainder, okay? And then 1 divided by 2, 1 divided by 2, what is the quotient? How many groups of 2 in 1? Nothing, 0, right? That's why the quotient is 0 and the remainder is 1. Once the quotient is 0, okay, I'm done. I have to stop. Any questions? Let's have another example. For example, I want to convert 125. 125 divided by 2 is actually the quotient is 62, and we have a remainder of 1. Okay, that means we have 62 groups of 2, right? Plus the remainder is 1. This is going to give you 125. Okay, that means when I divide 125 by 2, okay, I got 62 groups of 2 and 1 alone. It's not in a group. That's why if I multiply 62 by the 2, because 62 groups, in every group we have 2, and then you add 1, you're going to get 125. Is that okay? So And this quotient actually is a part of the result. This is so it's going to give you, don't be confused. The first digit you are going to get is the least significant bit, not the most significant bit. So you are, as you divide, you are going to get numbers right to left, not left to right. Because if you change it, to be completely different number, right? So as you divide, the first remainder you are going to get is actually, you are going to get them right to left, not left. Okay. So, and then I'm going to repeat again, 62 divided by 2 is actually 31, and the quotient is 0. 0 here is the second one here. Okay. 31 divided by 2 is 15, remainder is 1. 15 divided by 2 is 7, and remainder is 1. 7 divided by 2 is actually 3, and the remainder is 1. Is that okay? Sometimes here I got 1, okay? For example, here 1 divided by 2, okay? 1 divided by 2, the quotient is 0, and then I got the remainder of 1. So anyway, if you continue this way, you are going to get the digit here one by one. Any questions? Okay. If I want to do the opposite, very simple. That's what I explained before. Multiply every digit by the weight. 2 to the power 0, 2 to the power 1, 2 to the power 2, 3, 4, 5. And then add between that, you are going to get 47. So now you should know how can you convert any decimal to binary and how convert binary to decimal. Okay. When you go home and you do practice, you can try different numbers. Okay. But don't select big numbers. Otherwise, you're going to spend the whole night just doing divisions. You're going to have too many divisions. Okay. So anyway, just okay. Now, how I can do the same thing, but this time I want to convert. But yeah, sorry, I'm going to teach how can you convert to octal and hexadecimal. Okay, it's going to be exactly the same thing, but instead of dividing by 2, I'm going to divide by 8 or by 16. That's very easy. But before I do that, that's what I have already explained this one about when I give you the least significant digit, most significant digit, least significant bit, most significant bit, or sometimes we call it leftmost. This one is the leftmost bit, and this one is actually the rightmost digit. But most of the time, actually, because we're going to work in binary numbers, I'm going to use the word least significant LSB. This one is the LSB, the least significant. This one is actually MSP, the most significant. Now, I want to show you what I explained right now. If I give you a number without a decimal point, without a decimal point, how can you calculate it? Now, what happens if there is a decimal point? Okay, if there is a decimal point, so I'm gonna do it in two different ways. So or what I'm gonna do here, for example, if you have this number in decimal, okay, so I'm gonna take the part before the point, okay, the whole number part first, and then calculate and convert it, and then I'm gonna get the part after the point. I'm gonna convert, so I'm gonna do them separate, okay. So once I take this part here after the point, I'm gonna get this result here. Once I take the part before the point, so I'm gonna get this one here. Is that okay? I'm gonna show you how to do this one. I have already explained how can you do 85, okay, and also I'm gonna explain how can you do the other one. So let's first, I'm gonna do the whole number first, 85. Again, this is similar to what I explained. Just 85 divided by 2 is 42, remainder is 1. Okay, so here I got 1. Then 42 divided by 2 is 21, and the remainder is 0. Okay, so I'm going to continue this way until the quotient is 0. Okay, and remember, the number I'm going to get here is the least significant number. Okay, the least significant. That's why this one is going to come here. This one is going to come here. This one is going to come here, and so on. This is okay. Any questions? Now, how I can convert the fractional part, this fraction part, okay? Look how I'm gonna do it. Again, as I told you, I'm gonna convert this part alone, 85 alone, and after I converted it, that's what I got here, that's what I got here, okay? And this will be this part here, okay? Same thing, after I convert the fractional part, I'm gonna get this one. So I'm gonna show you how I did it. Okay. For the fractional part, the way I'm gonna convert it is, look here. I'm gonna, instead of division, I'm gonna multiply by the weight. So I took the fractional part alone. This is a fractional part alone. I'm gonna multiply it by the base, which is 2. The base 2. Okay. After you do that, okay. So I'm gonna get this digit, okay. So digit 0, and then I'm gonna get the rest, as you see here, is a fractional part, fraction, okay. Multiply it again by 2. I got this one here, so I'm gonna get this one here. This is the second digit I got, okay. And then here, then you take the fraction. So it's here. This one is 1.5. So I'm gonna get this number here. This is a part of the answer, and then I have 2.5. Okay, the fraction of ticket multiplied by 2 and so on. So here, and also I got here 1. So actually, the result here is actually, as you see here, 0, 1, 1. 0, 1, 1. Is that okay? By the way, you know, there are 2 cases here. One case, this part is not, sometimes it's not periodic. You got what I'm saying? Sometimes it's infinite. You have infinite numbers. Sometimes it's gonna stop at a certain, and in this case, it stop. So once you get 0 here, you have to stop, because here 0 times 2 is 0, 2, and so on. So you're gonna stop once you get 0 here, right? So that means the result here is actually you are gonna, it's only 0, 1, 1. Okay. Sometimes it's infinite. It's infinite. Okay. So like for example, dot 3, 7, 2, 5, 6, whatever. So you can stop after 3. After you get 3 numbers, it should be enough, or 4 numbers you can stop. You don't need to continue because it's gonna be infinite. You get what I'm saying? So again, what I'm saying, if you get 0 here, that means it's done. You are done. If not, sometimes it's infinite. Okay. So once you get 3, 4 digits should be enough. 3, 4 digits after the decimal. Any questions? Okay. Now, how I can do the same thing for octal and hexadecimal? I'm gonna repeat what I said right now, but instead of using 2, I'm gonna use the base 8 or 16. That's it. Pretty simple, right? Any questions? So let's see examples here. So for example, how can you convert a decimal to octal? Okay. So this is exactly the same thing but keep in mind, because here you are gonna divide by 8. The remainder should be a number from 0 to 7. Okay. Always the remainder has to less than a group size. The group size here is 8. So the remainder should be from 0 to 7. Let's see. So it's exactly the same thing I explained, just explained right now. For example, I have 165. Is that okay? When you divide by 8, divided by 8, I got 20. Quotient is 20, and the remainder is 5. Is that okay? Then 20 divided by 8, so the quotient is 2, and the remainder is 4. 2 divided by 8, quotient is 0, and the remainder is 2. Once you get a quotient of 0, you stop. I'm done. Now, the first one you got is actually the least significant digit. So that's why I made it this way. Here, so this is the least significant. So every time you divide, you are going to get 1 digit from right to left. That's 5, 4, 2. Once I get quotient of 0, stop. Any question? Okay. Okay, what if I have a decimal? What if I have a point? Okay. If you have a decimal point, it's exactly similar to what I explained before. Now you need to multiply by 8, as I did. I want to convert this part here. Okay. Number 1, you have to multiply by 8. Once you multiply by 8, the whole number here is actually part of the answer. And then you take the rest here. You take the rest, the fractional part. You take it. You multiply it by the base. Okay. Then I get here a whole number. So now I got, so here I got 0 point. In the first one, I got 2, then I got 5, then I got 7, I got 7, 0, and so on. Is that okay? Yeah. Now, I can continue. If you want to continue, you can continue, right? But how many? It's approximation. It's enough to have 4 digits. You can say maybe it's going to be infinite. Infinite. You have too many digits. Okay, it's enough to have 2 or 3 after the decimal. Okay. Any questions? If you get 0 here, if it happens and you get 0 here, it's done. Because if you multiply 0 by 8 anymore, you are going to get 0. You are going to stop here. But here in this case, I didn't get 0. And if you keep dividing, you are going to get more digits. Okay, but for sure, in this, it's enough to have only a couple of digits. Okay, 2 or 3. Any questions? Hexadecimal. I'm going to repeat. Yeah, this is just another example here. Just another example. So here, 540 divided by 8, the quotient is 67, remainder is 4. So this is, I got 1 digit from the answer. Then you divide 67 again by 8, the quotient is 8, the remainder is 3. Okay, this is another. So here I'm getting the answer here, right to left. In the first division, I got 4. Second one, I got 3. Okay. Now, 8 divided by 8 is actually 1, and the remainder is 0. So I put here the remainder, whatever remainder you get. But you have to be careful. This remainder has to be between 0 to 7. It can't be 8 or more. It can't. Okay? Because remainder means less than a group. Okay? So here you have to continue until you get a quotient of 0. Same thing, if you have a decimal point, as I told you before, you have to multiply by 8, as I explained here, okay? So here you can stop once you get 3 or 4 numbers, you can stop. You don't need to get 1 million numbers after the decimal point. You don't need to do that, right? After the decimal point, if you got 3, 4 points, 3 or 4 digits should be. Any questions? Okay. Now, same thing. If you want to convert a decimal to hexadecimal, it's the same thing. But this time I'm going to divide by 16, the base, instead of 8, instead of 2. It's the same thing. And again, because I'm dividing by 16, the remainder has to be number from 0 to 15. But remember, in hexadecimal, we don't say 15. We say F. You understand what I'm saying? So if you get 10, please call it A. If you get 11, call it B. Don't put 10. Okay. If you put 12, this is C until F, which is 15. Okay. For sure, when I divide by 16, I have to get a number from 0 to 15. No more than that. Okay. Anyway, so let's see. This is similar to what I explained. So, for example, I have this number. I'm going to divide it by 16. This is the quotient, and the remainder is 10. So I have to convert it into A. Because 10 is not allowed to use 10 as a digit in hexadecimal. 10 means A, okay? So I'm going to use A. Then I'm going to get this one, the quotient here, I'm going to take it, divide it again by 16. I get 21 and the remainder of 0. So 0 is a part of the answer, as you see here. So look here, I get first 15, and then I got 0, then I got 5, and then got 1. That's it, okay? So again, and now I'm going to divide 21 by 16. The quotient is 1, okay? And the remainder is 5. Now I'm going to divide 1 by 16. 1. How many groups of 16 in 1? 0, right? 1 cannot make a group of 16. That's why the quotient is 0 and the remainder is 1. Once I get them this way, so this significant one, next one. Any question? Very easy. Okay, what about if you have a decimal point? Yeah, same to as I explained to before. If you have a decimal point, something like this one, multiplied by 16. Once I multiply it by 16, the whole number here, okay, this one will be a digit in the answer. Okay, so I'm going to take the 13 here, 13 actually D, and then you take the fraction here, multiply it again by 16. Then this 15, I'm going to take this 15, right? Then I'm going to get the fraction multiplied by 16. Okay. So here I got 3. I'm gonna keep doing it. Okay. Either I get 0 here, or it's enough to have 3 digits. Okay. So again, the one I get first has to be here. You start from here to here. Next one here, it has to be here. Next one here. Any questions? What time is this crash should end? 2:15 or 2:20? 2:15? Okay. Okay, that's enough for today. See you on Wednesday. We're gonna do the next one. Thanks.